Hi, this is John from the Garmin Marine team. Today we want to introduce you to the biggest and most powerful members of our family, our marine radars. Radar can be an invaluable tool for navigation, especially when you have limited or no visibility. Radar can give you an extra set of eyes to help you see through the dark or the fog and help you determine what lies in the path ahead. With radar models ranging from 4,000 watts to 12,000 watts, and antenna sizes from 18 inches to 72 inches, you're sure to find a Garmin radar that fits your boat and your budget. We'll show you all the Garmin Marine radars in our family and help you choose the radar that will work best for you. Now, Garmin worked for years to develop the best marine radars in our own labs, and those labors have paid off with some of the most sensitive and high-performing radars on the market. And all of our radars will work with all of our MFD lines. There's no need to worry about what generation of plotter goes with what generation of radar. With Garmin, they all just plug and play. So no matter if you have a Garmin 700, 3000, 4000, 5000, 6000, or 7000 series display, you can purchase any Garmin radar and expect it to work well. Now, before we get into all of our radar models, let's take a few minutes to talk about how radar works and what you should look for in your radar. Radar is very similar to sonar in how they operate. Now, sonar works under the water, of course, while radar works above the water. But in both cases, a transmitter sends out a burst of energy, the energy bounces off the targets and reflects back towards the source, where a receiver picks up that return reflection and translates the time it took to receive the reflection into distance. The reflections are then drawn on a screen to show your position and the relative position of the targets. In addition, because the radar is rotating, we can determine not just the distance to the target, but also its bearing. A larger target will typically reflect more radar energy back to the receiver, which translates into a larger image on your screen. One of radar's key features is that it can see even when you can't. A moonless night, a fog bank, or rain can all severely limit your visibility, while the radar can burn through those conditions and see another boat coming at you in the fog, or make out that approaching shoreline even at night. So what makes one radar different from the next? Well, power output is one difference. As I mentioned, Garmin makes radars that output 4,000 watts, or 4 kilowatts, 6 kilowatts, all the way up to 12 kilowatts. The more power the radar outputs, the more energy that it can send downstream, and the greater possibility of that energy reflecting off the target and returning to the receiver. A more powerful radar will have a better chance of picking out a marginal target, and all things being equal, will be able to identify a radar target at a farther distance than a less powerful version. However, the more powerful the radar, the more it will cost. So you need to determine whether more power is a need-to-have or a nice-to-have feature. Now, the other big difference, in fact, the key difference between radars is the antenna size. This is a case where bigger really is better. The bigger the antenna, the better the resolution. To understand this better, we have to look at something called horizontal beam width. Horizontal beam width is a measure of how broadly or narrowly we can focus the radar beam as it emanates from the radar antenna. The wider the antenna, the more we can focus that radar beam. So in the case of our largest open array antenna, our 6-foot open array, we can focus that radar beam down to just over 1 degree. On the flip side, our smallest antenna, the 18-inch domed radar, physics only allows us to focus that beam down to 5 degrees. So what does that mean for you? Well, let's look at a scenario to help tell the story. Let's say you're offshore and you're approaching an unfamiliar inlet late at night. The inlet has a navigational aid on the north side and the south side, separated by a few hundred yards. So here you are, a few miles off the beach, you're approaching that inlet in the dark and trying to figure out where to go. The smaller domed radars will rotate around and see the buoys, but because of the wide beam width, the two buoys are seen on the same radar pulse and appear as one target. The open array, meanwhile, with its narrow beam, sees one buoy first, rotates a little bit, and sees the second buoy as a separate and distinct target. The difference shows up on your radar screen, one target versus two. The same thing would happen if you have two boats coming at you in close proximity. The open array will be able to separate those two radar targets better and more accurately and give you a better radar picture thanks to the narrow beam width. It's like comparing a spotlight to a floodlight. A spotlight can reach out and touch someone far away thanks to its focused light beam, while a floodlight just scatters the light all over the place and does not reach out very far. Another benefit of the larger antenna and the narrow beam width has to do with power. Let's compare these two radars. They both have 4,000 watts of power, but the open array can focus that 4,000 watts down to 1 degree, while the domed radar's power is spread over 5 degrees. That means that the open array will focus more energy on every radar target and have a better chance of picking out those marginal radar targets. Just remember that the larger the antenna, the better the resolution, and the more detailed the radar image. So consider moving to our larger dome or even an open array if you have the room. One more thing, when most people are looking at buying a radar, they want to know its max range. Well, okay, our open array radars, for example, with their narrow beams and their focused energy, support display ranges out to 72 nautical miles. Now, does this mean you're going to see another boat 72 miles away? Regrettably, no. Marine radars have a horizon too, just like your eyes. You can calculate this distance by measuring the height of your radar off the water, taking the square root of that number and multiplying it by 1.22. As an example, let's take a center console boat with a T-top. And let's say the radar is 9 feet off the water to keep the math simple. Square root of 9 is 3. 3 times 1.22 is 3.66. The radar's horizon, its limit of sight, is 3.66 miles away. However, we also have to take into consideration the height of the target off the water. So in theory, if your radar was looking at another center console that had an overall height of 9 feet, you could add another 3.66 miles to our distance for a total of just over 7 miles. Okay, enough math, let's get back to Garmin radars. First up, our most economical radar, the GMR-18. This digital 18-inch radar dome delivers 4 kilowatts of power, a max display range of 36 nautical miles, and a beam width of 5 degrees, all for a very competitive price. Now, the GMR-18 HD has the same specs, 4 kilowatts of power, 18-inch antenna, and 5-degree beam width. However, the HD stands for high definition. That means we've given the GMR-18 HD a much faster digital signal processor. That allows the antenna to crunch much more incoming data and turn all that extra data into more radar targets and better target resolution. Here, a picture's worth 1,000 words. These are from a radar test a few years ago. One boat with 2 radars mounted and going at the same time as it entered a mooring field. Exact same conditions, exact same settings, these screenshots tell it all. The picture on the right is from an HD version, which clearly separates the boats in the mooring field and draws a much more detailed radar image thanks to its faster computer. Next up the line is our GMR-24 HD dome. Same 4,000 watts of power, same max display range of 36 nautical miles, but with the larger 24-inch antenna, we can reduce the beam width down to 3.6 degrees. Remember, that larger antenna means a more narrow radar beam that will help focus the radar's energy downstream and help you separate radar targets better than a smaller antenna. Next up are the open arrays. We offer 3 levels of power: 4,000 watts, 6,000 watts, and 12,000 watts of power. We also offer 2 antenna sizes, 4 foot and 6 foot. Mix and match here. Pick the power level you want, pick the antenna that will fit, and you've got a complete radar system. And we've done it again. We've increased the processing power and speed for our open arrays in an effort to get a better radar picture. Now, we call these XHD versions, and they're a generational leap faster than any previous models. In fact, they can sample 8 times the amount of data that our standard radars could, giving you an unbelievably detailed and sharp radar image. The 4-foot open array antenna offers a 1.8 degree beam width, while the 6-foot open array offers the narrowest beam width at 1.1 degree. All of them offer a max range of 72 nautical miles, and all will plug and play into any Garmin MFD. You should have a good understanding of the basics of our radar, along with an appreciation of what makes one radar different from the next. We also introduce you to the whole Garmin Marine radar family. Hopefully, you have a Garmin on your radar now. If you have any more questions about Marine radar or any Garmin Marine products, go to garmin.com/marine or ask any one of our authorized installing dealers. Thanks for watching. We'll see you on the water.